All right, welcome to Point, Click, Tap, Touch, a session about building multi-device web interfaces. My name is Boris, and I'm a research engineer working on user interfaces in the Google Research Group.
And I'm Rick. I work on touchscreen support in Chrome, and I'm a member of the W3C standards groups working on standardizing touchscreen support on the web.
So today's talk's mostly going to be about input, and we'll talk a bit about mouse-based input, but the bulk of it is going to be about touch screens. So just to motivate that, I'm sure you've all got a touchscreen device, or maybe two, or maybe three, now that you've got pixels. And so touch is becoming even more ubiquitous than it was a year ago. Mobile use in general is projected to overtake the desktop sometime early next year. And the revenue forecasts of touchscreen modules only corroborate that. You can see it's a very up and to the right kind of graph. Also, we've got this relatively new form factor of touch laptops, of which the Pixel is one, and also Windows machines are becoming increasingly touch-enabled. Something like a quarter of Windows 8 laptop sales have a touch screen. So if you're a developer working on the web, you should expect your users to have a touch screen device increasingly. And the good thing here is that the web has a very powerful touchEvent API. And it's been around for something like 5-6 years and has become standard over the last 2 years or so. And the basics of this API is we've got a touch start event, which fires when your finger hits the screen. Touch move continually fires as you're moving around. Touch end and touch cancel are two different ways of ending that interaction. So touch end is the natural thing that happens when your finger is raised. And touch cancel happens if your touch gesture was canceled for some other reason. On Android, for example, if you start scrolling an area, touch cancel will fire as the browser begins to scroll. So to distinguish between these multiple touches, each one has a consistent identifier. This API that I'm describing works really well across a number of devices, basically across the whole modern mobile browser landscape. So let me quickly show you how this looks. On a Pixel, which is what I'm demoing from, I've got this paint application. You can see that as soon as I lower my fingers, I can do this amazing finger painting exercise. And we support up to 10 points. And you can see each finger has a unique color, which is because they have unique IDs. Now, if I didn't have a touch screen, I could emulate this behavior with just a mouse. And you can see I can override this by turning on emulate touch events in the Chrome developer tools. And when I do that, I get this little finger-like thing on the screen every time I move the mouse. And it's just a good reminder that says, hey, there's a certain size to your finger it's not as precise as your mouse. And I'll talk more about that. Now, of course, because this is a standard API, it works just as well across a variety of devices. So here I've got the same exact code running on a phone. And you can see that the behavior of this application is the same. OK, so I'll run through a couple of design suggestions, because designing for touch is quite different from designing for mouse and keyboard. So the first tip here is, obviously, touch interfaces require bigger targets. Your finger is inherently far less precise than a mouse, which can give you 1 or 2 pixel precision. But exactly how big? So extensive research has been done to suggest that 9 by 9 millimeters is something like the optimal touch target size. But the web has a few things that complicate matters. First, we've got a whole variety of devices to support. And they vary hugely in their device density. So PPI varies, and therefore it's hard to map physical size to device pixels. And secondly, the web has this concept of CSS pixels not necessarily being the same as device pixels, because they're modified by something called device pixel ratio. So with these two things in mind, we can do some calculations for a variety of popular devices. Here we've got the Nexus line, where we convert 9 millimeters into pixels, and we can see what that looks like on these devices. On the Chromebook Pixel, it's something, because of further distance of interaction, you end up with a slightly bigger, with fewer pixels required to represent the same physical size. So while we don't have like a clear guideline in this case of what size you should use, something between 42 and 58 pixels is our recommendation. And this is fairly consistent with other guidelines. Second tip is related to hover. So hover we can activate in two ways, generally with a mouse-based interface. So with CSS, using the :hover pseudo selector, and with JavaScript, using mouse over and mouse out events. With touchscreens, generally, with some exceptions like the Samsung S4, which has above surface hover, basically we don't have access to hover state. And even in the case of the S4, that hover state is only in hardware and available in Android. It's not exposed to the web yet. So what do we do in the case of touch for hover? Basically, here's an example of a hover test page. We've got two hover areas. One of them has a link, the other does not. And I can just activate hover by tapping. So a single tap activates hover on mobile devices with touchscreens. The problem is if you have hover and a link underlying that. So in this case, if I click this area that has a link, the hover state was triggered, but for so brief a time that the user didn't actually get to see it. So this happens a lot when you have menus, hierarchical menus that are activated on hover, and it's something to definitely avoid. Okay, the last designy kind of thing that I want to talk about is the touch laptop form factor and the kind of untapped potential that this form factor can bring. So there's two sort of axes here. First, we can think about switching between these two modalities of touch and not touch, and it might look something like this. So here's a gallery of photos. In this case, I've got photos of celebrities. You can see it's a very standard kind of interface, and I can pick new pictures with my mouse. It's great. So what happens if I want to use a touch device, or my touch screen in this case? This is way too small for me to tap. So you can see as soon as I tap this page, I get this responsive input effect. And now everything is far more tappable. So when I switch back to mouse, the page readjusts back. So this is an interesting concept that you might want to explore. Another possibility is to use both modes together. So in this page, I have a map that I've pointer locked. So whenever I pan around with my trackpad, or pinch zoom, or sorry, two-finger scroll, I can navigate the map. And I can also place waypoints on this map using my touchscreen. So it's sort of an interesting interaction using both touch surfaces simultaneously. And along the same veins, in this example, I have a small green rectangle that I can move around as you'd expect. But I can also simultaneously move my trackpad to rotate it, and with two fingers, I'll create a scaling effect. And I can do these things simultaneously. So it's kind of an interesting interaction that's only possible with these two touch surfaces simultaneously. So with that, I'll hand over to Rick to talk about some common problems and their solutions.
So in getting the Pixel ready to ship, we worked with a lot of different web properties to help them make their websites that were designed for desktop work better with touch. So what I want to go through here is some of the common issues that we came across that people hit regularly. First one is this code. Does anyone realize off the bat what the problem is with this code? Right, if you use it on a Pixel, you can't use the trackpad. And really, this isn't about the Pixel. This code was, the assumption here is if I've got touch support, like in particular the touch event APIs are supported on this browser, then I must be on a mobile device and I shouldn't listen to mouse events. And this was actually never correct. BlackBerry devices have a little trackball that sends mouse events, so this would also disable that. But this is really bad for touchscreen laptops. It means someone's got their laptop and they upgrade to their spiffy new touchscreen laptop, and now a site that they're used to using with their trackpad no longer works with the trackpad. Just because someone has a touchscreen on their laptop Doesn't mean they're going to use it all the time. In fact, a lot of users use it only for special circumstances, like maps and whatnot. And it really varies how much people will use the touchscreen on their laptop. So you really don't want to disable mouse support just because there's touch support. Let me show you an example of that. Not to pick on any particular site in particular, but this particular site, just to show you how frustrating it is. I move my mouse over these buttons, and clearly I should be able to click on these. But when I click, nothing happens. And it's really frustrating to say, why the heck can't I click on this? Until you realize, oh, actually, I can tap with touch. And that's just because they've stopped listening to the click event because it detects a touchscreen. So don't do that. So what do you do instead? So in the limit, don't try to predict whether or not the user is going to do touch. In the limit, you can't predict it. For example, they might have a USB touchscreen that's connected through a KVM switch, so it might come and go during the lifetime of the page. So you can't predict whether or not the user is going to use touch. Instead, what you should do is always listen for touch events and mouse events, and then you can decide dynamically. When you see a touch event get used, then you know the user is using touch. So in this case, we listened for both all the time. And I think the main reason people don't do this is for compatibility. Touch events by default, if I tap the screen, it'll send a series of mouse events to emulate a mouse click, so that all these websites that are designed just for mouse will still work by tapping the touch screen. And so I think the reason people stop listening for mouse events is they want to avoid getting that redundant click event. But the right way to do that is when you've consumed a touch event is to call prevent default on the event. Prevent default tells the browser, I've handled this, please don't do something else with it. And this is generally what you want to do anyway in most scenarios. You know, if you're using touch to manipulate an object, you don't want the browser to also use that touch to pan the page, scroll the page, for example. So let me show you concretely what that looks like. This is a really simple application that just registers an event handler on this blue box here. So you can see if I move my mouse over, it just lists the events that are fired. So if I touch and drag, I get touch start, touch move, and then whoops. If I touch and drag, you can see I get touch move and then touch end. But if I tap on this, you see I get touch start, touch end, as you'd expect. But then I also get this compatibility mouse move, mouse down, mouse up click sequence that's emulating the click. So to prevent that, I just go into my event handler here and say e.prevent default. Just say I've handled the event, please don't do anything else with it. And now when I tap, I just get the touch events. So if you leave here remembering nothing else, this is the most important thing. Don't make your users suffer just because they happen to have a touch screen. And now that you all have pixels, this will probably become pretty obvious to you. Try out your sites. Now, you don't have to have a pixel to test this out. So those of you watching in Extended or on YouTube that weren't as lucky to get a pixel yet, just go to Chrome flags and turn on enable touch events. We'd actually like Chrome to always support touch events. And the only reason we don't today is because so many websites have this bug. But hopefully at some point in the future, we'll make this the default mode. So you should turn this on and test your websites and make sure the mouse still works on your websites with this on. Another problem we see a lot is there's a subtle difference in how the events are targeted. So a lot of people will often, in many scenarios, want to delegate to the same code for touch and mouse. And there's a difference between the mouse event model and the touch event model in where the events go. So as you probably know, with a mouse, if I move my mouse cursor over like this blue rectangle here and press down, and then drag outside the rectangle, I'll get a mouse down, some mouse moves, and a mouse out event targeted at the rectangle. And then I'll continue receiving events on whatever the background element is, the white element in this case. It'll get the mouse over, mouse moves, and mouse up when I lift. This isn't the same for touch. For touch, the events always target the node where the touch started, as opposed to the node that's currently under the cursor as for mouse. So for touch, if I touch on this blue rectangle and drag across and lift, all the events are going to go to the rectangle, including the end. And this makes a lot of sense for common scenarios. If I've got a slider that I'm manipulating with touch, you'd really rather not have to worry about what happens if the user's finger falls off the slider slightly as they're sliding it. It makes sense to say, conceptually, when the user starts touching something, they're manipulating that thing for the duration of their touch. But this gets tricky if you think about what if you've got a container with some elements inside of it and it's changing over time. In particular, what if the element the user touched on happens to get deleted while the user's in the middle of their touch? This actually happened to me in some code I was working on, and I was really surprised. I didn't know what was going on. What happens is we follow this model. The events continue to go to the element where you started touching. Even if that element's no longer in the DOM, that's where the events go. They'll bubble up to the point that there's no ancestor, and they'll fall on the floor. So if you've got an event handler on a container, you're not going to get the events once the inner node is removed. And that'll look to your app like a finger's just stuck down. So I've got a demo of that. So this is a really simple app that just transforms this rectangle to match with my touch events. And this works fine because it's just a simple rectangle. But if this was a ticker or something with some changing content inside of it, or a list of email or something, then it would be more complicated. So I'm going to simulate that by just adding this red div every 2 seconds and then deleting it, and then adding a new one. So if I happen to start touching on the red div and drag around, as soon as the red div's removed from the DOM, it's what's receiving the events, and so the container doesn't know about the events anymore, and it thinks my finger's stuck down. And now my code gets confused. If I try to touch it again, it's confused because it missed the end. It never got an end. You see, I got touch start, and I got another touch start, which is really confusing for the code. So to fix that, the easy way to fix it is to just take my event handlers here, my move, end, and cancel event handlers. Really, I don't want those on the container. In this case, I want to take them, instead of putting them on the container, I can go up here to my touch start handler, and I'll put the event handlers instead on whatever the target of the touch start was. So in this case, it's going to be, if I started touching on the red element, it's going to be on the red element. Now, in theory, you might want to also go and remove these event handlers in the end event. But actually, it's not necessary because adding the same event handler more than once is a no-op. So there's no disadvantage here to just adding them and leaving them there. So now you can see if I start touching this red guy, now it's removed from the DOM. It doesn't really exist anywhere except it's being kept alive by the events that are being sent to it. And so the JavaScript code can still be fired and see those events, even though the node's not reachable in the DOM anywhere. So that's how to fix that one. Right here, just like that. Another common problem is dealing with small targets. Lots of the web is designed for a mouse today. So the browser's got to do something to make it easier for touchscreen users to hit small things. If we just relied on looking at the center point of your finger, it would be way too small. So as Boris said, ideally you'd have larger targets. But if it's a site that's designed for a mouse, or if you want to try to strike some compromise on your site where you don't want things to be giant, then the browser's got to do something to make it easier for people to touch small targets. So what Chrome does, it's got a feature called touch adjustment. And what it does, the green rectangle here represents the bounding box of my touch. Using the radius from the hardware on Pixel, we know the radius of the touch. But if we don't know the radius on other hardware, we can use a suitable default. And then we look at all the elements inside that bounding box. And we'd find every one that has some signal that it's activatable by tapping somehow. So it's got a click event handler, or it's got an active CSS pseudo class. Anything that we expect something will happen when it's tapped. And we score those based on how far away the edge of that element is from the center of the touch, and how much of that element gets overlapped by the touch. And we pick the one with the highest score, and then we adjust the touch. We don't change the raw touch events. Touch events are a low-level API. We don't want to muck with those. But for the compatibility mouse events, we'll shift them. We'll change what element is targeted, and we'll change their coordinates so that it actually gets delivered to what we think the user is trying to touch. Let me show you that in a demo. Oh, pro tip, by the way, for all you with your new pixels, Control-Shift+. We haven't put it in the UI yet, but we have a nice UI rescale feature. You can zoom in and out the whole Chrome OS UI. So I'm going to do that for this demo and show you. So let me just show, if I just tap here, I've got the rectangle showing where my tap was, and the blue shows where the click event went. And in this case, there's nothing touchable underneath, so there's nothing unusual here. And if I tap on top of a link, again, there's nothing really unusual. But if I tap on the boundary of a link like this, you can see my touch end event, which is the red dot, occurred on the X and T in the word text here. And down in the log, you can see the touch end event occurred on this ID called content, which is the text content. But I overlap the link. And so the browser sees that overlap, and it adjusts the click event so that the click is actually going to the link, which is the blue dot next to it. And there's all sorts of different signals that we use. So the link is the obvious one. But anything with a hover effect, like right here, this text turns red when you hover on top of it. So you can see I'm adjusting down towards it. Or something with a tab index. Right? A tab index indicates that you can focus it by clicking on it or activating it. Or even just a mouse down event handler, because we fire those on tap as well. So these are all signals that tell us that something's touchable. And so this works great most of the time. but it is possible to confuse it. In particular, we need some signal that what you've got is designed to be activated somehow. And if you're relying on event delegation, so for example, you've got an event handler on your entire document, and then in JavaScript you're deciding, oh, this event actually really was on this element, and I'm imperatively in JavaScript going to reroute the event to the right element, that gives the browsers no real signal of what is touchable and what isn't. And not only is that going to disable touch adjustment, but if there's other signals like hover effects and active effects, it might actually make touch adjustment behave worse than not having it at all. My favorite example of this is Gmail, unfortunately, and we'll get this fixed at some point soon, but whoops, let me go back here. So I can tap these stars and activate them no problem, and that's because the star in its unactive state has a hover effect that makes it look slightly different when you hover over it. And so it looks tappable to us, and so every time I touch near it, it'll adjust towards it. But if I try to tap to turn off the star, it's incredibly frustrating. I just keep hitting the things next to it. And that's because these other things on either side of it appear to us to be tappable, but there's no longer any signal on the star telling us that it's tappable. Gmail is using event delegation, so there's no event handler on it, and there's no longer a hover effect or anything. So as far as we can tell, it's just random background content. And so we don't think it's something the user is trying to touch. OK, another question I get a lot is, how should you recognize more complex gestures like pinch or rotate? Mobile Safari has a proprietary API for this called gesture event. And IE10 has a proprietary API for this called MS gesture event. So in Chrome, we're not going to add another proprietary gesture API. We think proprietary APIs are bad for the web. We'd love to have a standard API that works across all browsers. Thanks. Thanks. First time I got applause for not doing a feature. I love it. And we'd love to have a standard API that all browsers can implement, but for various reasons, it's not going to happen anytime soon. But the good news is, you actually don't need the browser to do this for you. This is something that can be done perfectly well by libraries, built on top of the touch events. There's a wide variety of different libraries, and then you can use one of these libraries and have it work across all these browsers, not have to worry about the differences in the browsers. So I wrote a little demo here using hammer.js, which exposes a whole slew of different types of gestures. But the transform gesture in particular recognizes pinch and rotate. Let me just show you what this looks like. So with a very small amount of code, I can handle moving this box around, pinching it to zoom it, and rotating it. And I haven't had to listen to touch events at all. I've just done this, listened for transform events, and imported the Hammer library. So if you want to deal with gestures, I encourage you to explore these libraries and contribute to them. Most of them, I believe, are open source projects. Much better than a proprietary browser API, in my opinion. And now back to Boris to talk about performance.
All right. So one performance issue you may have seen or heard of is this infamous click delay. So the idea here is clicks on mobile browsers are generally delayed by something like 300 milliseconds because the browser needs to decide if your click was a genuine click or if it was actually a double tap. So there's this gesture where you want to zoom into some content that's very small, and you double tap to that, and the browser zooms in. And so this behavior can cause pages to feel very slow and unresponsive. And if you've been working in this space, you've probably heard of fastclick as the solution to this. And what fastclick basically does is, instead of using click, it uses just the touch end event, which is something we described earlier. So of course, you know now that there's some drawbacks to using touch end versus click, such as the touch fuzzing that Rick described earlier. And you lose that if you use a fastclick library. So in cases where we don't need a fastclick library, we should avoid it. A couple things also changed over the last year or so in Chrome. Firstly, Chrome Desktop, which has touch support in some cases, like in this Pixel, or on Windows devices, there's no click delay because we don't actually support the double tap to zoom gesture. So
another feature, by the way, we're never going to support because we're not going to add 300 milliseconds to the click events.
Excellent.
If I have anything to say about it. Sorry.
And in Chrome for Android, we have an optimization that landed over the last year that doesn't create a click delay in the case of a fixed viewport. So you can fix your viewport with user scalable equals no. And in that case, again, the double tap gesture doesn't exist. So there's no need for us to delay. So it's important that the fastclick library that you use is aware of these changes. Otherwise, you lose the benefits. So we worked with FT Labs, which support like one of the most popular fastclick libraries. And they've patched their code to make sure that their library is smart about this. So keep that in mind next time you're using a fastclick approach. OK, another performance issue. You may have written or seen code that looks like this. So this code essentially just renders every time you get a touchmove event. The problem with this is that touchmove can fire very quickly. Often it fires much faster than your render loop, which is 60 hertz if you're getting a smooth performance, smooth visual display. In some browsers, this problem is mitigated by coalescing multiple touch events into one. So there's touch arrays that come with every touch event. And it's up to the browser, basically, to decide if it should put all the events together or if it should create separate touchmove events. So let me just quickly show you here on a mobile device the possible issue. So here I've got some code that basically does this naive approach where it renders everything on touch. You can see I've got one finger. I'm just drawing the point, and that works really well. I can add a second finger and a third finger. You can sort of see the slowdown now, but as I add the fourth finger, things really degrade. So this is not what we want. So touch events are piling up, and basically we're not able to render quickly enough. And there's a big backlog of touches, which is why you see this delay. So the solution to this is to avoid expensive operations in your touch handlers. Well, in general, this is good practice, but it's especially important for touch. So rather than rendering, you can store the touches and then set up a separate animation loop with something like request animation frame, which makes sure that every single render is tied to the vsync of your display. And just by doing this small optimization, let me show you the difference. So I'll switch to the request animation frame version. There we go. And you can see that same four-finger gesture is now extremely responsive, just with that one small change. OK, another performance issue is related to scroll jank. So in case you're not familiar with scroll jank, the basic idea is sometimes scrolling can be very uneven and just not be very responsive to your actual input. And this can come in many forms. But we've done some studies, and it's very important for engagement. So if your users are dealing with a janky site, it's likely that they won't come back. And Chrome team has spent a lot of effort trying to optimize this scrolling. And the big push has been to move scrolling to a separate hardware-accelerated GPU thread. Event handling, though, is still, of course, on the main thread. So there's something that can happen if you have a fairly busy main thread, because every time you scroll, as Rick pointed out earlier, you can prevent the default behavior of a scroll. And the way we do that is in JavaScript by using event prevent default. So what happens is every time you scroll, we need to call back into, well, Chrome calls back into the main thread to see if it's allowed to. And if the main thread's really busy, that causes the GPU thread to wait. So here's how this looks. I've got a artificially busy main thread in this page. And I've also enabled a empty touchmove handler. So it just looks like this. It's a no-op. And if you see me scrolling here, my finger is moving smoothly. It's very janky. So by simply turning this off, I have a very different experience. And that's a no-op touch handler. So what's the story here? How can we avoid this? Well, first, and quite obviously, we can just not use that touch event handler. If it's unnecessary, there's no need for you to put it there, and you'll save yourself from seeing this issue at all. And of course, remember that in some cases, it's not so bad to rely on synthesized DOM events like click, scroll, and context menu, which all fire on touch devices. So basically, what I'm saying is you don't need to implement touch-specific event handlers necessarily to have a good experience on touch screens. And another approach to solving this problem is if you definitely do need a touch handler, make sure that you've contained that touch region to be as small as possible. So Chrome has optimizations that says if the part of the page that the user is scrolling doesn't have a touch handler, then there's no need for us to call back to the main thread. And we can just do the thing very quickly. So essentially, if you think of your page as if you think of subdividing your page into regions, you can decide whether or not you want to optimize for smooth scrolling or for touch event handling. So this example that I showed you earlier is the worst case, where you've got a touch handler on your whole body for no good reason. OK, back to Rick.
So we've told you a bit about the state of touch on the web today. I want to touch briefly on some of the directions that we want to head going forward. So first of all, here's just a rough idea of some of the goals that we've got. First of all, as we talked before, touch events are a pretty low-level API, and a lot of times you want to express your intent in a higher-level fashion. So we'd like to do more to eliminate the need for you to drop down to this low-level API. For example, a really common scenario is to want to support dragging things around, right? Drag-and-drop type UIs. And there's actually a high-level drag-and-drop API for the web today. Unfortunately, it's only implemented for mouse. Every browser that supports drag and drop only does it with mouse input, which seems a real shame. So we're starting to experiment with this in Chrome OS. You can try it on your Pixel. You can turn it on in About Flags. It's touch-based drag and drop. Long press will initiate a drag and drop. And we're hoping that we're going to get that on by default in M29, which is coming up in a little bit. And then once we're happy with it there, we're going to turn it on the other platforms as well, Android and Windows. We also want to give you more control over the browser's default behavior so that you don't have to fall back to touch events. So a really common scenario with touch events is an image carousel, where you want to support swiping between the different images. And really, that's just a scrollable div, except that you really want to snap where it stops to image boundaries. And so what people end up doing is they use a library or they write custom code to listen for touch events, and then they have to implement all of scrolling themselves, which doesn't sound that bad until you realize that there's a certain physics that people are used to, and they're used to a certain momentum when you fling, and then trying to match that to the browser's behavior, which is changing and different between browsers, is very hard. And then all the work that we do to try to scroll on a GPU thread so that we're not subject to jank from the main thread, all that goes out the window when you implement scrolling in JavaScript. So we'd love for common scrolling scenarios like that, we'd like to just give you features that let you customize the behavior, like add snap points. IE10 has a feature for this, and so we're talking with Microsoft about how we can standardize that, bring it to the standard web. And we're working with other browser vendors to bring new web standards to help with touch as well. So in particular, IE10 has a number of touch features that are pretty nice, so we're talking with Microsoft about those. In particular, pointer events is a new input model in IE10. IE10 doesn't support the touch event model that we've been talking throughout this slide for. They've got a different input model called pointer events, and it has some design properties that we're pretty excited about. First of all, it abstracts different types of input. So you still need to think about touch and mouse as separately when you're designing your site, but sometimes the right thing to do is to handle them the same. And if the right thing to do is to handle touch and mouse the same, you should be able to use the same code to do it. And this model extends the MouseEvent model, which means if you've already got a big investment in code that's designed for the mouse model, you can, rather than having to worry about things like the difference in targeting model and the lack of over and out events, you can update that code to work with pointer events very easily. We'd love to see more discussion on pointer events. This is the mailing list for the standards group. Love to hear discussion there. The implementation, obviously IE has an implementation, and Firefox has said they've started to work on an implementation. Microsoft built a prototype for Chrome, which is great. And now we've just announced that we're going to start landing some experimental support in Blink for pointer events. But adding a new input model isn't something that we take lightly, especially when it's redundant with existing models and not necessarily something all the browser vendors are going to embrace. So we're starting by adding some features that are going to make it easy to build high-performance, high-quality polyfills for pointer events. And then we really want to get feedback from you guys. We want to see, like, if you vote with your feet by using the polyfills and send us signals that you really want this model natively in the browser, then we'll add it to Chrome. So today, there's a few early polyfills. None of them are perfect, but they're all pretty good and a good way to get a handle on how pointer events work. If you went to the web components talk earlier, the application of web components, the Polymer framework, they decided that pointer events was the right input model for Polymer. So they've built a polyfill that emulates pointer events that you can use completely independently. So please check those out and send us feedback. So I'm not going to go into full details of the Pointer Events API. Microsoft has a bunch of good links. There's lots of full talks on their own. But I want to touch on two things that I'm particularly excited about. First of all, I said that they let you specify declaratively what to do with touch. And this is done through a CSS property called touch action. When you say touch action none, it means you don't want the browser to take a default action on touch, like scrolling. And instead, you just want to deliver events. Where if you say touch action auto, then that means that you want the browser to determine what to do. So for example, as soon as you start scrolling, the browser says, oh, I'm supposed to scroll now, and it can start scrolling immediately and just send a cancel event to JavaScript to say you're not going to get any more events now that the user has started scrolling. And it doesn't have to block on the main thread. So that scroll jank problem that Boris showed, which can be a real problem, especially on mobile devices, just goes away completely with this. I also said that this can be better for code sharing, right? We really want to enable you to build sites that work well across a range of devices. And so let me show you an example here. This is a really simple demo of drag and drop that's kind of modeled after the Google Plus Circle editor. The idea is I can touch on a card and drag it. Whoops, let me get all three of my circles here. Touch on a card and drag it to one of these circles. And it's designed to work with multiple inputs. So I can touch two cards at once, or I can even use a mouse and touchscreen at once to drag things around. And so let me show you what was involved to make this work. There's a bit of code here, so I won't go through all of it. But the move handler is perhaps the most interesting. When the mouse moves, I just have a little bit of work to do, really, and then I delegate to this common move function. But when I get a touch move event, I'm going to delegate to the common move function. But then I got to do a lot of other stuff to compensate for the difference in targeting model. And this is all specific to the touch model. And then the common function for handling movements is like a couple lines. It's unfortunate. This is the only thing I can do in common. And the start and end events are like that as well. It's a pretty small amount of common code for the two cases. Where if I use pointer events, I can get the amount of shared code from about half the lines of code being shared for the two scenarios up to 97% in this case, and get the number of lines of code I had to write down from 131 down to 89. Let me show you what that looks like. In this case, since Chrome here doesn't have pointer event support, I'm using the points.js polyfill. And so with much less code, now I can still support dragging things around with touch and mouse simultaneously. And you can see that there's very little code here to handle the difference between mouse events and pointer events. I basically just have to check to see if the browser supports pointer events. And if so, I'm going to use events that start with the word pointer instead of the word mouse. Otherwise, the events are the same. And in order to handle multiple things moving around at once, if I'm using pointer events, I'll use the unique identifier per pointer. But otherwise, if I'm using mouse events, I'll just use this constant one. And otherwise, all the code's the same. The move event handler is just this here. And then I have over and out handlers. And so for this scenario where I really want the same thing to happen regardless of the type of input, I can dramatically reduce the amount of code I have to write and have to test, which is a big part of it. So those are the reasons that I'm excited about pointer events. We'd love to get your feedback, start using the polyfills. And hopefully we'll see it in Chrome at some point in the future. So that's it for the future. And we've given you a few tips now for how to make your sites work great on touch. Now that you all have pixels, please try out your websites and apply these tips and make your sites awesome on touchscreen laptops. And then if you have any problems doing that, we want to hear about them. You know, this is an area of the web that we're trying to make better and make more consistent across different form factors and different browsers. So please, we want to hear about it. The public web events mailing list, this is the group of the W3C that I'm a member of that works on touch events. That's a great mailing list to give us feedback on the touch event model. You can also reach out to me directly on Google Plus or Twitter. And Boris and I are going to be available to take questions. I guess we've got like 1 minute, I guess. Maybe we can take, you know what, why don't we take one question from our extended audience? We've got thousands of people watching around the world. And take one quick question. Please submit feedback using this URL, and then we'll be down here to take any live questions.
Okay,
let's just you got the Doria? Do we have any?
Maybe a live question. How's that? We'll take one.
We have one live question? OK. Do we know we're awesome? Well, we do now. Thank you very much.
Thank you.
Right.